Hi there, how are you doing today? This is Pranav from DBS Diary. Uh, in the previous video, we talked about interview questions and we covered the answers. And I see that there are many who like this video, and so I thought let me cover another set of questions of SQL Server, and we'll go through answers one by one. It will be again like 15 questions. So we'll start with that. So it will be again 15 set of questions along with answers. So if you like my channel, please do like, and if you want to cover something specific, please do comment, and please subscribe so that you will come to know what all things I'm working on and I'm publishing the video. Okay, so we'll start with the 15 interview questions again for SQL Server. Okay, let's start. So 15 interview questions. So in these questions, if I have to cover the lab, I will go through the lab and I will show you like how it really works and what all things we can do. So let's start with the first question. This is very much generic questions, okay, like very much generic question, and it could be asked by an interviewer to you. So it is not about the right answer or wrong answer. It is just about how you explain it and what all things you talk about that is very relevant. Okay, so how many indexes are required to be there in a table, and how many is too many and how many is too less, right? Now this question is being asked to you by the interviewer. So how will you approach it? What will be your answer? There is no fixed number as such. You cannot say I need to have 5 index, I need to have 10 index, I need to have like certain number of index. And you cannot say that no, I need to have no index at all, right? So it depends. But then if you say only it depends, then it's not really answering the question. So you need to specify like why indexes are required and why it is not required. I mean, in case you say no, I should not have any index, then why is that, right? So if you have a table which is read sensitive, okay, or read intensive, so in that case the structure of index will be different and number of index will be different compared to the table which is write intensive. Okay, suppose you have a table which is read whole day and written into it only one time in a day when the end of day is processed or some process is there which writes into that. So in that index, in that table you can have more number of index compared to the table which is written very frequently and it's very hot, right? So I have a table. I can give you one example of my application. I have a table which is of 100 gigs plus size, okay, and I have more than 10 index on that, and most of the indexes are having more than 5 or 6 columns, okay. That table is read very frequently by my application, okay, and written into it only one time in a day when the end of day is performed. So in this kind of thing, in this kind of scenario, it's perfectly fine to have more number of index compared to the scenario when it's written more frequently. Now take an example, like you have a data warehouse, right? So this is something when you have an environment called pre-staging, right? You have the source system, then you have target system. So in between there is a system called pre-staging, wherein you just dump the data and load it. So in that scenario, in those table, you don't need to have index. Even cluster index you can skip. You don't need to have cluster index because you just dump the data, and that dumping should be very fast. So insert should be fast, and then you truncate it. So in that scenario, in those cases, even if you don't have a clustered index, it's absolutely fine. So there is no any concept or there is no any number that you can come up with, but you can explain having more index will impact performance of insert, update and delete, whereas having more index or having supportive index will help in select operation. So you have to balance it. Okay, so based on the number of read operation or write operation, you can judge like how many how many index should be there and how many should not be. And I mean, this you cannot drive at day one or week one. You need to, it's a continuous or it's a like progressive thing. You again check your tables and the usage of index every week or maybe every month. Depending on that, you can take a call, right? So this was the first question. So I would expect the candidate to explain all this thing, like why this many index and why not this many index, right? Okay. Now, second question is why primary key should be a clustered key and not non-clustered. See, you can create the primary key having both options. Like you, by default, it will be clustered, but you can define non-clustered, right? So when you define cluster or when you don't define anything, it goes for clustered. That means your data is ordered physically in that order, and it is also part of all your indexes. So that is very supportive when you query the table. If it is non-clustered, in that case it will go for row identifier, okay, RID, and then it will try to fetch the record. So it's not sorted. So insert will be faster, but then any operation on the select will be slower. Anything on the join will be slower. Then your any like maintenance job and all that will have some issues, right? So it is preferred to have, I mean, this is best case scenario. This is no best practices. You should have primary key as a cluster, unless and until it is very much justified by your application or by your database architect. You should not go for non-clustered primary key. Okay. So this was second question. Now let's go to third question. Why foreign keys should be indexed? Now foreign key, as you know, it is one key in a table which will be linked with another table's primary key. Okay. So this I will try to explain with the help of lab. Okay. So maybe this will help you understanding. Now see, for instance, I am trying to join table here batch and users. Okay, so this query will actually give me the what all batch this user has got, okay, whose name is Jeff Atwood. Just I took a random number, okay, and then let's see like how it works. So here I am joining on the user ID column of batch table with the primary key of users table, right? So these two columns are like, this is foreign key in this table, in the batch table, and it is linked with the primary key of users table, right? It will take a while because we don't have index. Okay, let's see. Now see the execution plan. Clustered index scan for the complete this table, users table, and this will also go for clustered index scan, right? Because we don't have index on this. And how many read it has done? So if you see, it's 142,000 for users, as we had seen in the previous video, and this one is 169,000 pages. So if we create an index on user ID column, which is actually a foreign key, so this will help us in any join. Okay, so if you have an index on the foreign key column, this will help in having join running much faster. This is why it is like one of the best practice to support your foreign key with the indexes. Okay, now if you see the same query which we ran before, it took a while. It will be much faster now, and you can see it has come down from 169,000 to 1,000 pages. So that is the magic of index. So that is why it is advisable to support your foreign key with the right indexing, right? Okay, so let's go the next question now. How to read missing index details and interpret to create index. When you have a number of queries running on your database, and if you don't have a supportive index on the table, so how will you read the missing index and how will you create that? This is something very tricky question, and I don't think this will be very easy if somebody gives you this question and then they explain this scenario. So this is something lab based. Okay, if you are able to answer this question with right analogy, this is really good. This will really explain that yes, you have very good experience and you know how to design the index and how to work on it. Let's see this. Now we have in equality operator and inequality operator. Okay, actually I have made this missing index based on the query that we had covered previously in our previous video, right? When we had like conditions on the reputation, location and display name. So let's see how we see how we can create an index based on this. Okay, so I will not take include for now because include is mostly to do with the star, right? So we'll just remove it, include for now in this session, but we can also use index afterwards. I mean, we can also use include afterwards. Okay, so let's try to create index only with the equality and inequality operator. Okay, so this check index is nothing but SQL blitz index, which is provided by Brentoza. I have just renamed because it sounds more meaningful to me. Instead of using like BLITZ, I use check. It is more like meaningful to me and more easier to make out. Okay, so you can see display name. Now you have location and you have inequality reputation. Okay, so here you have equality display names. It is same column. It is same column, right? Now here equality is location and inequality reputation. So if you can see, display name is actually there in all the places, right? Display name in all the missing index part. So what we'll do, the first column that we should take is display name. See, this is like comma delimited value. This is comma delimited columns which will appear in this. It doesn't have any specific order. You need to order it, and as you know, in the index, order is very, very important. So I will take the first column which appears in almost all of them. So first should be display name, right? Second one, I mean, if you see 1, 2, so there is only one which does not have display name. Then the next one comes location, and third one, if you see, it is about the reputation. Now reputation is coming in the inequality operator. Inequality operator means, you can say, which is not exactly one value. It is like range of value. So let's try to create a query to show that what is the meaning of missing index and what exactly is the query which will use that index. Select a star from users, where let's go with the equality operator first. Okay, so where display name is equal to, say, for example, Abhi, or okay, let's go with this. So if you see the, let me put into a different window. I'll enable the execution plan. Let's see. You see this is missing index detail, and this will be on the equality operator on the display name. If you see here, missing index detail, you will see create on clustered index, name of this on users display name. Okay, so this will be equality operator. Now the second one which we saw was also on the equality, right? Equality, which is location, so it will be location. Now inequality, which is not equal to, or greater than, or less than, or not in, or not exist, there are many. So reputation, you can say greater than, see, for instance, I will give like 100,000. Okay, so this is inequality operator. Now this has gone for clustered because it is because we don't have index, but it did not give you the this one means missing index details, so it will be here. I think I missed something here. Something I missed here. Okay, so this is like range of thing. So the inequality will take precedence over the equality. So in that case, I would prefer to have an index starting with reputation. Then I will take display name and location. So this is what I will create an index with. I will not go with like 1, 2, 3, 4, 5. No, I will not go with 5 index, because all 5 are having almost similar columns. So I will go with one index with 3 or 4 columns depending on the missing index details. So this is how we design the index, and you have to also see what is the impact of it. See, since this is lab, I will not too much focus on the estimated impact here, but in your scenario, in your production environment, you can really see it will be in the millions. Okay, we should not touch something which is having very minimal impact. Okay, so I hope this one helped you. Now let's go to the next question. How do you design an index if you know that it's going to be a hot table, however no index script is given by development team or vendor, you have data in the table. Actually this one we covered in the previous video, wherein I explained about the column which is numeric or number type, and it gives you advantage of converging the things, okay, so that you can if you specify that column, it will go very less number of record, less number of rows. So that's how we should design. So like I explained in the previous one, that reputation column in the users is very good, okay. If that condition has been specified, it would go and find the specified number of rows, and that will be very much like what you say, it will return you very less number of rows, instead of if you think like except the reputation is equal to 1, right? So if you specify location is equal to India or United States or United Kingdom, or display name is equal to LX or something like that, that will not be that much selective. So based on selectivity on the columns of table, you should create an index, or you should design an index. You should see my video wherein I explained all that. Okay, why is it preferred to have multi-column index over single column index? Now this is something which we saw in the in the previous question, wherein I explained in equality operator and inequality operator how it works out. And then if you have so many indexes, like you have like 10 to 15 indexes of one column, instead I would prefer to have less number of index with more number of column. So it would help you in having less blocking, okay, and less block will also result in less deadlock, okay. Locking will not escalate and all that thing will happen. But again, this is generally, it depends on your application also. Suppose you have an application wherein it's very much required like 1 column index or 2 column index, so depending on that you may take a call, okay. Should you extend memory of the server if PLE is low? What is PLE? PLE is page life expectancy, okay. So this explains like how long the page will remain in the memory and before it got flushed out. So see, this is not the only parameter which should enable you to extend memory. This is one of the parameter, but then you need to also see what is the wait type, wait events on your server. Is it only one factor which is impacting it? Is it slowing down the things? If nobody is complaining about your server, if it is like behaving normally, and you don't have any wait event which is really alarming, then I don't think you should change the memory or you should extend the memory. If everything is going fine, you should focus more on the indexing and support them with the right index, or drop the unused indexes compared to simply thinking of adding hardware, okay. Let's go to next question. Suppose you are a junior DBA, you just have joined and you don't have too much of experience. So you have not been granted sysadmin role by senior DBA, but you still want to see the execution plan. So what permission should you ask? So show plan is one permission that you should ask your senior DBA directly. So that will actually help DBA to understand that yes, you already have some idea about the show plan and how the plan works, and how to read the plan, how to interpret the plan, how to make out whether index what is available there is sufficient, adequate, or you need to create more indexes. So if you ask direct question to your senior DBA and straightforward like what is required, it would be nice for a senior DBA to think about you that yes, he or she has good understanding. Difference between lock, block and deadlock. See, lock is very important. Locks are of different type, right? You have intent lock, you have exclusive lock, you have schema lock. There are different types of lock. So to maintain the ACID property of OLTP database, this locking is very important and crucial. So when you update a record, when you update a row, when you update a table, when you update one specific column, so you need to lock that particular row or range of rows or the full table. So it has to lock that, and then it has to modify that and release the lock. That's how it works. So locking is very important, and the importance of locking is it should be released immediately. You should lock it, yes, but then you should release immediately. You should not lock it for extended period of time. You should lock and release immediately. If you hold the lock, that's when the issue starts. And locking should be at a very modular level. You should not lock the whole schema. You should not lock the complete table, exclusive lock. So for that we create indexes. For that we have to fine tune the query, right? We have to use the right operator. Then block. Block is something which is, suppose you are updating one record and at that point of time only somebody else is trying to read the record. So at that moment that the other session gets blocked because you are trying to update something. So as I said in the previous question log, that you should release immediately. So if you release the log immediately, the blocking will be cleared. There is no mechanism by SQL Server that they will clear the block. You have to clear it, or when you release the log, it will be cleared by itself. Blocking is something which starts if you have too much of blocking on the database, then this will result in deadlock. Because suppose you have a process A and you have process B. Process A is trying to modify something on the process which is used by process B. Now process B is trying to modify something on process A. So both of them are waiting for each other to release the log, and that's when deadlock will happen. So in order to prevent deadlock, you should first target to remove the blocking. If you manage to clear the blocking, you will not have deadlock, right? Okay, so how can now the next question is like 10th question. How can you transfer SQL Server job from one server to another server? See, this is something when you have like when you're migrating your server or when you're upgrading your databases from one version to another version, you need to transfer all the job. So one way is to export all the job, like right click on, if you go to Explorer, Object Explorer, and you select all the job and you can say create job, you can right click and create the script and you can do that. That's one way. Other way I could think of is you can take the backup of MSDB and restore it, but this has limitation that this will work out only when the source version of SQL Server and target version is exactly same. There is no difference at all. Then only it will work. The third is you can do through SSIS. Okay, so whichever way works for you, you can answer the question like that. Can you create clustered index on views? Actually, yes, we can create unique clustered index on view, and I have explained this in my previous video, wherein we have focused on only one query, which is always using clustered index, and then we have improved the performance of that. So this is very handy when you have so many columns in the select operation, and you are unable to do anything to improve performance with indexing. So in those scenarios, we do create unique clustered index. It is schema binding, so it's an indexed view. Limitation, yes, limitation means it you cannot use table of different databases. You cannot have max aggregate functions. There are many things like that, so it has its own limitations, so you need to consider them before really implementing it. But yes, if everything is falling within your acceptability of indexed view, it is very good, it's very handy. What are the default port for SQL Server? If you change them, is it dynamic change? Can you have more than one listening port? Default port for SQL Server is, as you know, it's 1433 TCP port and 1434 UDP port. If you change them, yes, if you change them, is it dynamic? No, it's not dynamic. You need to restart the SQL services. Okay. Can you have more than one listening port? Yes, you can have more than one listening port, but you cannot have one database listening on one port and another database listening on another port. Both databases, I mean all databases on that instance will be listening on all the port that you specify in the connection level. Okay, so it's not that you can have different ports on one instance. You will have all the ports listening on all those ports, right? Okay. What are the operators which prevent parallelism? How to check it? Which trace? This is something which is very advanced level. I don't think everyone knows about it. And if you know, then I would really say that you are really good and you have very good experience. Okay. I did not know it for a long time. Recently, I came to know about it. So there are certain operator which prevents parallelism. If you specify them, then parallelism will not be chosen by your optimizer. Okay, so you can search for it. Like there is something called parallelism inhibitors. Okay, there are some good article from Paul White, and there is one video from Adam Mechanic as well, and there's an article from Eric Darling. So you can see all of them. So suppose we have a query. So when and there are few operators, like top is one of them. There are few more. You can search for that, and if you could answer this question, it's really super. So you can see now this execution can actually, there are three trace or hint which can make your query parallel, and it will help you in identifying those queries which is not going parallel because of those keywords. So you should try to remove them by changing your query. So there are one see, top is one of the operators. So if you specify trace flag 8649, this is one of that, and then you have something called enable parallel plan, enable parallel plan preference. This also helps in generating the parallel plan, but this will work only from after 2016 version. Before that, it may not work. So if you compare the execution plan of these three, so you can see that first one is having only one parallelism, wherein the second one, if you see, it is having parallelism here as well as here. Okay, the third one, actually second and third, both of them looks exactly same. So it's doing the same thing. So it's either trace 8649, or there is an option called enable parallel plan preference. Okay, so this will tell you that whether your keyword is inhibiting or stopping the optimizer to go for parallelism. So if there is parallelism, it will improve the performance. I should not go, but I just want to show you something here. It's 41 millisecond here. No, this is not something you can't relate it that easily, because it's very trivial query. So just wanted to show you the example. So this may not be that much effective. Okay, so leave that. Okay, now the next question is, give some example of wait type which can bring your SQL Server down or dead. See, SQL Server bringing it down does not mean that SQL is not accessible at all. It is something like your server is dead slow, or it's not responding at all. Your server is very good all the time, but suppose at one specified time every day, or at any point in time, it becomes totally unresponsive. So that is as good as dead or down, right? So that should not happen. So you need to find out those wait types which can cause these things. Okay, so see, SQL Server works on three things, right? One is CPU, second one is memory, and third one is IO, right? These three are main things. So if any of these three becomes unstable, or it gets totally occupied by something else, or by your SQL Server itself, and it's not able to say, you can say, let's start with the IO. So if you are unable to write or read from your physical device or from your disk, so then you will start getting one specific type of wait that will cause this. Second is your memory. So if you have some like full utilized memory, or you have some memory leakage, when you are unable to use memory even for compilation or for anything, you are unable to get the grant, so then it will get this. Not able to get the grant is not the only thing. When you have when you don't have no space at all, there is no like available memory for you to get anything, that's when it will happen. Then third one will be your CPU, right? So all these three, when they are fully utilized or when they are unstable, that's when you will get all these types of waits. So it will be like you can say thread pool, you will have semaphore, and you have anything to do with the IO, right? So if you have these wait types, then you should immediately check if it is to do with the CPU or memory or IO. Okay, so any of this could really slow down your server. Now, meaning of SARGability. Now this is like SARGability or SARGability, whatever you say, it is search argument. So in this, you need to have a where clause wherein it should match with the column of that table. Okay, so it should not do implicit conversion. If you have varchar, then you should not pass like n varchar column. I mean, if the column is n varchar, you should pass the argument as n varchar, not varchar. So it will not do implicit conversion. Date time. Okay, there are certain fields like no char, n char. There are things which will make it non-sargable. So if that is the case, if you have date difference, if you have date greater than, okay, date less than, and then you are not specifying the same data type, then this thing will happen. This is a huge dampener for SQL Server performance. So you should check if there is a yellow band implicit conversion on the left side of your like plan. So if there is anything like that, then you should check that, and you should make your queries as much as sargable as possible. This will help in improving the performance and having this issue you can eliminate. Okay, so this is all about 15 questions today, and I hope you liked them. I didn't smile much in the in the questions. Okay, so I'm smiling now. So if you like them, please do like and please do comment. And if you like my channel, if you like my videos, please do subscribe. Okay, so thank you for watching. We'll have more videos coming soon. Okay, thank you very much. Have a nice day. Thank you. Bye bye.